this video, we're going to review graphing basic log functions. So over the next few days, you'll be working with some graphing, and I find that log functions tend to cause kids much difficulty, so I wanted to take a moment and review how to graph them. Many of you did really good on finding the domain of log functions in the first or the second day of class, so just keep that skill in mind because it can help you to determine the graph as well. So let's start with something like just a basic graph f of x equals log raised to of x. Now, since logs are a little awkward, I think, for most people, especially students, the way I like to handle graphing these is, well, first of all, I'm going to change f of x to a y, and view it more like this, and then I'm just going to write this equation in exponential form. So if y equals log base 2 of x, remember what that means is 2 to the y equals x. And the reason I find this easier is because now I'm just going to make a table, and it's easier to fill out the table when you think in terms of exponents. I think it's more natural. But keep in mind, since things are sort of reversed, since I have like x equal to 2 to the y, I'm going to plug in values for y. It seems more logical to do that. So like for instance, when y is 0, I get 2 to the 0. So when y is 0, I get 2 to the 0 equals, well, 2 to the 0 is just what? Of course, it's just 1. Anything with 0 is 1. So when y is 0, x is 1. Let's plug in 1 for y. 2 to the 1 equals, well, we know that means, or anything to the 1 is just 2 itself. So 2 to the 1 is 2. So when y is 1, x is 2. And we're going to do one more, because we really want 3 good points on a log graph. How about 2 when y is 2? 2 over 2 equals 4. So when y is 2, x is 4. Now, question. Okay, well, actually, let's graph what we have now so far. I've got 1, 0, 2, 1, and 4, 2. So at this point, I think we can tell that goes through this. Now, students sometimes will just stop here because they're good at making a table for the values they know, but they can't really make the leap conceptually to what's happening in this section over here. Alright, so let's make note of one thing. First of all, many of you noted that the domain of log functions is always 0 to infinity. So we probably know that there's not going to be much, or there's not going to be anything to the left of the y-axis. Okay, so that's one thing to notice. The other thing to notice is that, look back at this equation here, 2 to the y equals x. Is there any way you can get 0 as an output to an exponential? In other words, 2 to something equals 0. Remember that exponents are repeated multiplication. Can you multiply 2 times itself any number of times to get an answer of 0? No, and even if you do negative exponents, you'll never do it, because remember, negative exponents tend to turn into fractions, depending on what the exponent is. So this has no answer. In other words, the x value can never be 0, right? So when x is 0, there is no y value that's going to make this true. That's why there's our vertical asymptote there at x equals 0. Okay. But what's happening between 0 and 1, between x equals 0 and 1? Well, just note that, again, we're going to use this representation of our log graph. 2 to the 1 equals x. Well, let's pick some really small fraction. Like let's pick this number right here, and let's say that's 1 over 32. So that's x, remember. So if x is 1 over 32, I've got 2 to the y equals 1 over 32. Now I chose 32 because I know that 32 happens to be 2 to the 5th. So now I've got 2 to the y equals 1 over 2 to the 5th. But remember, 1 over 2 to the 5th is the same as 2 to the negative 5. Now if you match it up, that means that y is equal to negative 5. So when x is 1 over 32, y is down here at negative 5. Okay, so our graph is going to continue like this. And if I could keep going, I mean, I could keep picking even smaller numbers, like 1 over 64, which is even smaller than 1 over 32. And if I did that, I'd find that y is negative 6. The point is, I can make those values as small as I want, and what's going to happen is that the y value is just going to continue to decrease. Okay, so that explains our log shape. Now, one thing I want you to know is that all log shapes all basic log graphs have the same shape. And what I mean by that is they all have this basic shape. First of all, this point 1, 0 is always going to be on all of them. And it's important for you to go back to the table and think about why. There's nothing special about the 2 that made us have this point 1, 0 in the graph. What will change is whatever that point is there, and perhaps this other point here, but the point is they're all going to have this shape. So if you're ever expected to sketch a log graph, it's always going to have the same shape here. These two boxes are going to depend on your base. Our base here was 2. If your base was 3, that's going to change those numbers, and it's important for you to think about why, what those numbers would be. Okay, but there's a basic log graph, so you want to be able to graph that, get 3 points on the graph, and get the basic shape for any log graph.